Okay, so we're breaking these up into shorter little snippets of wisdom, and here we're going to tackle how to figure out what type of statistical analysis you need to run. And really, it all comes down to your hypothesis. So you've got a research objective or a working research hypothesis, and in order to figure out what test you want to run, there are some simple questions that you have to answer about your data and about your analysis. And first of all, that includes what type of data you're using. And when I say what type of data, I'm talking about the nature of the data you've collected. Is it continuous data? Is it counts of observations, how many times you see a certain result? Is it a categorical variable? Is it ordinal? Is it nominal? So just knowing what both your independent and dependent variables are is going to automatically direct you to different families of statistical tests. So that's the first thing. What's the nature of the data you have? The second thing that helps you figure out what test to use is figuring out what type of research question you're actually asking. If you're looking for differences between groups, it's going to take you into the ANOVA family. If you're interested in relationships among variables, it's going to take you into the correlation family. Or if you're looking to either model or predict outcomes, it typically takes you into the regression family. Right? And within each of those families, there's lots of different options, but this is at least going to get us to the right branch in that dichotomous tree. Then you want to think about how many variables you're comparing. Are there multiple variables that you're using to model something, or are there multiple variables that you're trying to look for relationships among, or are there only two? How many different groups are you comparing? And if you're comparing differences in groups, whether or not you're comparing two groups is going to be a very different test than if you're comparing 5 groups. All right, so think about that as well. And then also you have to consider your experimental design. When you selected those observations, were they truly independent from each other, or were they purposely paired in a paired design? And then finally, the last question would be whether or not your data is normally distributed. Because typically all of these questions will get you down to one specific test. But each test will often have a non-normal counterpart. In other words, the same test but constructed so that it will work with non-normal data. So that's another important consideration when figuring out what test to run. And I'm just going to give you an example of some of these different dichotomous keys. So we start at the top, and notice this one starts out with really right off the bat, what's the research question? What are you focusing on? Are you looking for relationships between variables, or are you looking for differences between groups? If you're examining relationships, it brings you down to this branch, and then it asks you, okay, well, how many variables are you dealing with? If it's only 2 variables, oh, well, there you go, it's a correlation. Right? If you're looking for more than 2 variables, you may be into a regression factor analysis or a canonical analysis. So again, keep in mind that there's multiple tests underneath each of these. Some keys will break them out farther than others, but at least it's getting you towards a more specific group of tests that you can look through. Now, if I were looking at differences, I'd come over to this branch. Now, what this is getting at when it says, are the same participants being tested more than once? That's getting at that question of independence. When you selected your observations, were they truly independent of each other, or are they purposely paired? Now, I don't really like this key because it just lists it as, well, are you testing it more than once? And if you are testing an observation more than once, clearly it's not independent, right? Because you're going back to that exact same observation a second time. That would be purposely paired, right? But you can have other examples of paired data beyond just going back to the exact same observation and measuring it a second time. So really, I think of this as are your observations independent or dependent? If they are dependent on each other, then we'd go to the yes. Again, it asks us how many groups we're dealing with. If it's 2, we have a t-test for dependent samples. If it's more than 2 groups, we have a repeated measures analysis of variance. If we have independent observations, again, how many groups? If it's just 2 groups, it's a t-test, and if it's more than 2 groups, it's an ANOVA. So this is just one example of a key you can use. I have another one that's a little bit more complicated, and this one works it the other way around. It actually starts by asking about the nature of your data. Really, if you have frequency data, this would be counts. It knocks you off right away. If you're talking about count data, you're just into the chi-square analysis. But then over here, it's again asking about the research question. Looking for differences or looking for relationships? How many variables? How many experimental conditions? So this would get into how many independent variables are you using.
Here we are getting back into whether or not we have independent or dependent observations. Right? And then this one breaks it down into the parametric, which would be the test you use for normally distributed data, and its partnered non-parametric test, which is what you would use if your data was not normally distributed. So that's one nice thing about this key, is that it breaks it down into your parametric and your non-parametric options. Right? A little bit more complicated, but it could be useful. One more example, again, starts with the research question. Relationships or predictions. Discrimination is looking for differences between groups. This one now includes looking for group membership, so this is really interesting. It gets into the nature of our variables. If you're trying to predict an outcome that's categorical, like maybe I want to predict whether or not a habitat is high quality or low quality. Those are two categories. I'd be getting into this sort of discriminant function or logistic regression. So each of these keys includes different tests, and it really depends on whoever's pulling together the key and which tests are important to them that determines which ones they include. There is no one perfect key, but I think what I would suggest for this class anyway is that as we go through this, you guys can create your own dichotomous key. Right? So think about all those questions that you had to go through, right, when figuring out what type of test you want to run.
So as an example, that one sample z-test is going to be the first inferential test that we learn, and so I could start to build out this dichotomous key of my own, knowing that for me it's really nice to think about the type of response data first, whether it's continuous, counts, or categorical, and knowing that my one sample z-test is something I do with continuous data. I can then come down and figure out if I'm looking for differences or relationships or making predictions. One sample z-test, as you'll see, is about seeing if some value fits a given population, a one sample. And then there it is, one, so I can have my one sample z-test or its non-parametric alternative. As we go through each of our inferential tests, we will continue to fill out this key, and if a different key works better for you, make it that way. We'll also come up with actual lists of criteria. For those of you who aren't the key type people, you're more of a list person, we'll do that as well. For example, we could say you're going to use this test when you're asking a specific question and you only have one sample that you're using. And then it also lists some of the criteria, the assumptions of that test. So whichever works for you, that's great. But the key to all things statistics is not to panic. There are lots of tools out there to help you figure out which analysis you should use. So hopefully that's enough to get you started.